Hello students, welcome back to our discussion of Chapter 5, Interval Estimation. In the last video we learned about our first type of confidence interval. It's an interval when the population standard deviation is known, and it's an interval based on the population average. So we're going to look at this example. A random sample of 100 business people revealed that, on average, they spend $450 per month on parking costs. The population standard deviation is 125. Construct a 95% confidence interval for the average monthly parking cost. So this is a great example for us to work on. What we have to understand with confidence intervals before we actually develop it or build it is what we are trying to calculate. We want to know this. This is the population average. This is not known. We don't know what the population average is. For us to calculate the population average, we'd have to ask every single business person within this environment or within the city, and ask them how much they spend on parking costs per month. That would take a lot of time and money. So we take a sample. We're going to survey a set number of business people in this case, because taking a sample saves time and basically saves money. So that's the two main advantages for us for sampling. Instead of asking every single person or entity within the population, we take a sample. It saves time, saves money. The cost, or the major concern with a sample, however, is that it is not accurate. But if we develop a proper enough sample, we could state our level of confidence or accuracy. So basically we are stating we want to develop an interval estimate that has a 95% confidence interval. So we're going to write down some of the key values that we need. Remember, this X bar symbol here is a sample average. So we take a sample, we find that they spend on average, right there, $450. The population standard deviation is given to us, 125. Our sample size, a random sample, 100 business people. And the confidence level is stated at 95%. Remember, in the previous video, 95% confidence interval gives us a Z value of 1.96. So our confidence interval formula is going to be a sample mean plus or minus this key Z value times the standard deviation of the population divided by the square root of the sample size. So 450 plus or minus this 1.96 times our 125 divided by the square root of 100. Put that in brackets because we're going to multiply that by 450. So 450 plus or minus 1.96. I'm going to do this separately. This turns out to be 12.5. And now our final statement we need is this: 450 plus or minus 24.5. So we are 95% confident that this value, the population average, is somewhere between this interval. The population mean most likely will not equal $450, but we're saying that it's somewhere within this range, 450 plus or minus 24.5. If we wanted to have a smaller interval, we would have to survey more people. But the number of people we survey, and we'll come to this later on in the chapter, is based on many reasons. Based on accuracy, but it's also based on how much time and how much money we have. We're doing the best we can given the resources that we have. So this here is our final, this is the confidence interval. That's what we need to leave it at, 450 plus or minus 24.5. With this interval estimation, we can answer a couple questions. Remember the standard error? The standard error is this symbol here. The standard error equals the population standard deviation over the square root of our sample size. So this was 125 over the square root of 100. The standard error equals 12.5. The margin of error, I'm going to abbreviate that ME, sometimes it's just abbreviated E for error, is basically the Z value times the standard error. The population standard deviation over the square root of the sample size. So this would be 1.96 times what we have in there, 12.5. So this was 24.5. What are the upper and lower limits of the interval? Well, the interval estimation was 450 plus or minus 24.5. Everything after the plus and minus number is this margin of error. So the upper limit will be 450 plus 24.5, and the lower limit will be 450 minus 24.5. So this would be 474.5, and this would be 425.5. How confident are you that the population mean, this symbol, is within this interval? We are 95% confident. So if we were to do this sampling process 95 times or 100 times, 95 of them would include this value of the population mean. We'd have a 5% chance of error. Remember, alpha is a chance of error, 5% chance of error. Chance that our sampling process or our values are going to be incorrect. So we are 95% confident that the population mean is somewhere between $425.5 and $474.5. So let's work on another example. Example 2. Last month, John sent 850 packages by courier. He would like to know the average cost of sending a package. So he takes a random selection of 35 packages, which had a cost of $10.50. We're going to assume that the population standard deviation is $1.22. Construct a 95% confidence interval for the average cost of sending a package. So John wants to know this. This is unknown. This is the population average. So he does not want to go through all 850 packages one by one to calculate the average. Maybe these are just filled in, maybe there's just boxes and boxes of receipts. He does not want to go through each and every receipt because sampling, if he takes a sample, it saves time and money. However, it's not 100% accurate. So it's always a balance between accuracy and time and money. So perhaps this is a day before Excel, where you would have all your receipts or any type of software, accounting software, that you would actually have all your receipts entered in a system. So this is probably back in the days when everything was just kept on paper and you have boxes for your old receipts. So he does not want to go through all of this. So let's write down what we know. The average cost from the sample was $10.50. The population standard deviation is assumed to be $1.22. The sample size is 35. He just randomly selects 35 receipts. But we also have this number. We know that there's 850 in total. So population N, or population size, capital N, leads us to that other correction factor that we need for the standard error. And we are developing a 95% confidence interval, which leads us to a Z value of 1.96. So our confidence interval is going to be sample mean plus or minus a Z value based on half of alpha and the standard error. We could write the standard error as this: standard error equals population standard deviation over the square root of n. This is what we used previously. However, because we know the population size, we have to make an adjustment. This is the finite correction factor adjustment that we have to make. So we're going to do this one calculation separately. The standard error equals 122 divided by the square root of 35, and we have to all multiply that by the square root of 850 minus 35, which is 815, divided by 849. So the standard error, this first part is going to be approximately 2062. This last part, 9798. So in total, the standard error equals 202. So now we can put the standard error back into our confidence interval calculation. So we know that sample mean is 10.5 plus or minus a Z value 1.96 times 0.202. So 10.5 plus or minus approximately, it's going to be rounded up to about 40 cents. So this is how we're going to leave our final answer. On the exam, writing something like that would be correct. 10.5 plus or minus 0.4. So what does the standard error equal? Remember, the standard error was that value we calculated. The standard error, including the correction factor, worked out to be 202. The margin of error, when we multiply the standard error by Z, the margin of error was 0.4 approximately. The upper limits, 10.5 plus 0.4, 10.9, $10.90. The lower limit, 10.5 minus 0.4, $10.10. How confident are we? The question states to develop a 95% confidence interval for the population average, population mean, of the receipts for the packages. So we are 95% confident that this value, the population mean, is somewhere within this range of 10.10 to 10.9. 10.1 to 10.9. So somewhere between $10.10 and $10.90. So we'll come back in the next video to learn about the second type of confidence interval estimation.